Welcome friends. In previous lecture we have seen the shear reinforcement concept and how to provide shear reinforcement, what are the different guidelines from the IS 456 regarding the shear design. Okay. Today we will solve the numerical on the shear reinforcement, shear reinforcement design for the rectangular beam. Okay. I will read the numerical first and then we will proceed with the solution. A beam of size 300 mm by 1010 mm, 1010 mm effective size has a span of 7 meter. The total load on beam is 45 kN per meter. The tensile steel is 6 22 mm diameter bars. If concrete M15 and mild steel are used, design shear reinforcement. Okay. Now see, the width of beam is given 300 mm. The depth of beam is 1010 mm. Load on beam, total load on beam is 45 kN per meter. ASP is given 6 bars of 22 mm diameter. FCK is 15 Newton per mm square. Fy is mild steel, means 250 Newton per mm square. And the span of beam is given, it is 7 meter. Okay, the shear force is not directly given, we have to calculate it. So shear force for the uniformly distributed load simple support. So maximum shear force will be equal to 45 WL by 2. So 45 into 7 into 2. Now it is not factored load, it is total load. So when you have to calculate the VU, you have to calculate it factored. So I will multiply it by 1.5. So from this you will get the shear force, factored shear force, design shear force 236.25 kN. Okay. Now this is the value of shear force. Now we have to calculate the shear stress, nominal shear stress tau v. As per our design procedure, we will calculate the nominal shear force tau v. VU divided by PD. VU divided by PD. It's a formula. VU is now 236.25 into 10 raised to 3. It is in kilonewton. I will put here in Newton because I want this tau v value in Newton per mm square. Okay. So B is 300 and D is 1010. If you calculate this, it is 0.779 Newton per mm square. Now I will calculate tau c max for the comparison of this tau v, means whether this tau v is okay or not. For that you should check it with the tau c max value. Now given grade of concrete is M15 and for M15 maximum permissible limit for tau c max is 2.5. Okay, so it is less than tau c max because tau c max is 2.5 Newton per mm square. Okay, so then it is okay. Now we will calculate tau c. We will calculate tau c. So tau c is calculated based on the grade of concrete, then percentage reinforcement of steel. Now percentage reinforcement of steel, you delimit or PT you can say, it is AST divided by BD into 100. So AST is 6 bars of 22 mm diameter divided by BD into 100, it will be equal to 0.7. Okay. Now if we refer the chart of IS 456 and in that chart for given grade of concrete, that is M15 and percentage reinforcement 0.75, if you calculate the tau c value, you will get the tau c value as 0.54. Okay, if you check this tau c value for PT rim is 0.75 and M20 grade concrete. In previous lecture I have shown you the chart. In same chart you have to check the value of tau c. Okay, for 0.75 is the value of PT. No need to do the interpolation. You will get this value of tau c directly from the chart. Okay. Now we will compare this tau c with tau v. So tau v is 0.779 and tau c is 0.54. It means tau v actual stress existing in beam is greater than tau c, that is shear taken by the concrete or maximum shear capacity of the concrete. So it means tau v is greater than tau c. It means you need to provide a shear reinforcement. You need to provide shear reinforcement. Okay? Only nominal minimum shear reinforcement is not sufficient for this case because tau v is more than tau c. So what is the amount of shear to be registered by the shear reinforcement or vertical stirrups, you can see. So it's a tau v minus tau c multiplied by Vd. So tau v is 0.779 means 0.78, 0.54, 230, 1010. Okay. If you calculate this, you will get it's a 72,630 means 72 kilometers. Now you can see here, out of this total force 236.25, extra force that is 72 kilonewton, 236 मध्ये 72 किलोन्यूटन जे आहे ते एक्स्ट्रा फोर्स आहे. त्यासाठी तुम्हाला काय करायचं आहे, shear reinforcement डिझाइन करायचे. The remaining force can be resisted by the concrete alone. The remaining force can be resisted by the concrete alone. Okay. Now you will provide. You have three options. You can provide vertical stirrups, you can provide inclined stirrups, or you can provide bent up bar and vertical stirrups. Okay. So for this example, we will provide only vertical stirrups. It is very simple form of shear reinforcement. Okay. So for that, first of all, you have to fix what is the diameter of vertical stirrups. Okay. So provide two vertical stirrups of diameter, let us say 6 mm. Okay. Now diameter 6 mm. Now what is ASB? ASB is the pi by 4 into 6 square multiplied by 2 because it's a 2 leg, so multiplied by 2. Okay. Now we will calculate value of SV, that is 0.87 Fy into ASB into D divided by Vs. That is a formula. Okay. Now substitute all the values. 0.87 Fy is 250, ASB is pi by 4 into 6 square into 2, D is 1010 divided by mu 72630. So its spacing value is, if you calculate this, you will get the value of SV as 171.039. Now you can't provide this value directly as a spacing for this beam. You have to check this value with the minimum shear reinforcement criteria, as I have told in previous lecture. Okay. So what are the minimum reinforcement criteria? So minimum reinforcement criteria is one. First criteria, SV is equal to Fy into ASB divided by 0.40. You have to calculate this spacing by this equation. So if you substitute all the values again, 2 pi by 4, 6 square, 250 divided by 0.4 into B is 300. Here it is 117.8. Again this is 117.8 and this is 171.39. So it means this value is less and this is 4. Okay, so you can't exceed the spacing above this value, that is 117.8. You have to provide at least this spacing. Okay, so again this is not enough. Again you have to do more checks, that is 0.75 D. 0.75 D is 1010. Now this is also approximately equal to 750 and 450 mm. Okay, so this is one value, this is one, this is one, and this is one. So total values of spacing are 4. 117.8, 750, 450 and 171.39. Which is minimum? Minimum is 117.8 mm. So you have to provide spacing, it is 117.8 mm. You cannot provide this 171.39. These values are also high. Okay? Means कमीत कमी जी value तुम्हाला या calculation मध्ये निघेल ती तुम्हाला as a design shear reinforcement spacing जी असेल ती तुम्हाला ती value provide करायची. If you calculate this 171.39 into directly provide this 171.39, your answer is incorrect. You have to compare with the minimum shear reinforcement criteria. From minimum shear reinforcement criteria is 117.8. आता इथं कन्फ्यूज व्हायचं नाही. स्पेसिंग कमी म्हणजे रेन्फोर्समेंट जास्त, स्पेसिंग जास्त म्हणजे रेन्फोर्समेंट कमी. 170 आता इथं तुम्ही जो नाव 117.8 आणि इथं 171 आहे, इथं 750 आहे, इथं 450 आहे. हे जास्त आहे ते प्रोव्हाइड करायचं. जास्त म्हणजे जास्त रेन्फोर्समेंट आहे का नाही. स्पेसिंग जास्त मीन्स रेन्फोर्समेंट कमी आणि spacing कमी means reinforcement जास्त. So you have to provide the minimum spacing which is calculated from all these 4 equations, 4 guidelines, 1, 2, 3 and 4. So this is minimum. So I will provide 6 mm 2 leg stirrups at 118 mm center to center. 118 mm center to center. आता कधी कधी ही व्हॅल्यू सगळ्यात कमी येते. ज्यावेळी शेअर फोर्स जास्त असेल त्यावेळी ही व्हॅल्यू कमी येते. मग ही व्हॅल्यू तुम्हाला इथे घ्यायला लागेल. ओके, म्हणून सगळी कॅल्क्युलेशन केल्याशिवाय आन्सर डायरेक्टली लिहायचा नाही. ओके, सो वी हॅव सीन हाऊ टू प्रोव्हाइड अ शेअर एन्फोर्समेंट for the rectangular beam. Now there is one more part, that is zoning part. One more part is there, that is a zoning part, in which now say this 118 for this particular beam, we will say that this 118 you have to provide across the whole length of beam. The total length of 118 provide that. But suppose when you have to achieve economy, in that case you have to divide entire beam in different zones. And according to the variation in shear force, you have to provide the reinforcement. Shear reinforcement means if you draw a shear force diagram from particular beam, suppose this is a beam which is subjected to UDA. Now if you draw the shear force diagram for this beam, shear force diagram will be like this. And maximum shear is PWL by 2 at support. then the maximum shear force जो है तो कुठे आहे support ला आहे. But what is the shear force at the center? It is 0. आपण डिझाइन करताना जे shear force घेतो ते कोणतं आहे? WL by 2. इथं तेवढं आहे का? नाही, इथं shear force कमी आहे. म्हणजे आपण जी reinforcement कॅल्क्युलेट घेतली ती केले ती ह्या शेअर फोर्ससाठी आहे, इथल्या शेअर फोर्ससाठी नाही. म्हणजे इथं जर तुम्ही रेन्फोर्समेंट कमी दिली तरी चालेल, कारण ते शेअर फोर्स तेवढं नाही. म्हणजे झोनिंग म्हणजे काय, तर शेअर फोर्सच्या प्रपोर्शनेटली रेन्फोर्समेंट प्रोव्हाइड करणं, त्याला म्हणायचं इकॉनॉमिकल डिझाइन ऑफ शेअर रेन्फोर्समेंट. म्हणजे ह्या रिजनमध्ये शेअर फोर्स कमी, ह्या रिजनमध्ये मी काय करेन, जेवढी गरजेची आहे मिनिमम शेअर रेन्फोर्समेंट तेवढीच प्रोव्हाइड करेन. इथून पुढे शेअर रेन्फोर्समेंट, इथून पुढे शेअर फोर्स जास्त आहे, सो इन दॅट केस आय विल प्रोव्हाइड the design reinforcement which is calculated by this equation. Okay, so this is called as zoning. Now see, आता ही लेंथ कशी ठरवायची, ही लेंथ ठरवताना तुम्हाला टाउसी व्हॅल्यू वरून लेंथ ठरवायची. टाउसी is the shear taken by the concrete, let us say it is 0.75, and what is VC? This shear stress, so VC is shear force carried by the concrete, so we multiply by T. आता ही व्हॅल्यू कुठे तुम्हाला चेक करायची, आणि ही व्हॅल्यू तुमची समजा इथे 100 आणि ही व्हॅल्यू तुमची आहे 75. ही व्हॅल्यू समजा तुमची इथे 100 आहे, इथे 75 आहे, आणि इथे -75. ओके, म्हणजे 75 च्या खाली शेअर फोर्स गेला की तो शेअर फोर्स कोण रेजिस्ट करू शकतो, कॉन्क्रीट इटसेल्फ कॅन बी रेजिस्टेड, कॉन्क्रीट इटसेल्फ विल रेजिस्ट द पर्टिक्युलर शेअर फोर्स which is less than 75, but shear force which is above the 75 you need shear reinforcement. म्हणजे इथून पुढच्या रिजन मध्ये शेअर फोर्स जास्त आहे, सो इथे तुम्हाला शेअर रेन्फोर्समेंट हेवी पाहिजे, आणि इथून ह्या रिजन मध्ये ह्या मधला जो रिजन आहे इथे शेअर रेन्फोर्समेंट कमी आहे, इथे शेअर रेन्फोर्समेंट कमी आहे, इथं शेअर फोर्स कमी आहे, सो इथं तुम्ही मिनिमम शेअर रेन्फोर्समेंट क्रायटेरिया प्रमाणे जी काही तुमची स्पेसिंग येते ती तुम्ही इथं प्रोव्हाइड करा. आता यात पण तुम्ही अगदी मिडलला गेलात तर इथे शेअर फोर्स कसा आहे 0 आहे, सो इथं तुम्ही आणखीन तुम्हाला हवं असेल तुम्ही स्पेसिंग ती कमी करू शकता, पण मिनिमम स्पेसिंग क्रायटेरियाचा तुम्हाला बियॉन्ड जाता येणार नाही. मिनिमम स्पेसिंग जे क्रायटेरिया जे आहे ते तुम्हाला फॉलो करावे. ओके, सो दिस इज हाऊ द झोनिंग फॉर द बीम इज मेड, बिकॉज in high-rise building number of beams are there. If you save some quantity of steel in one beam, for entire whole building the total quantity will be much more as compared to the cost of the reinforcement. Okay, so today we have seen the shear reinforcement of a rectangular beam by limit state method. Okay, if you are having any doubt, queries, you can ask me. You can ask in comment also. If you want to ask, you can ask me from the WhatsApp, or you can call me also. Thank you.